Thanks for coming out all the way here, not just to Wales, but also to the furthest room in the conference centre. There's a water machine at the back for people to get their breath back after the exercise and getting here. But I'll just introduce my my talk. It's about PowerShell and its implementation of regex expressions for matching text. Kind of like why to be good at it, and kind of like how to start being good at it and improve at it. And I'm going to kind of like be kind of putting a few train spotting jokes in there as well, because Train Spotting was released in 1996 and I was 8, so I wasn't allowed to watch it. And as a family, age 34, we all watched it over Christmas, and I kind of thought it was quite punchy, quite epic. So I'm just going to weave a bit into that without overdoing it. But so to start with the questions slide, if you want to ask a question at the end, you can scan, choose Live, choose a massive TV, choose Regex, choose PowerShell, choose a Q&A, feedback QR code. The code's there. If you want to, you can scan it. You can get to the Canopy app where you can ask some questions for later. It's only a 20-minute talk, so there won't be a huge amount of time, but we'll try and get a couple of them in. About me, my name's Ned Stratton. I'm a data analyst specialising in the Microsoft stack, working in SQL, Power BI, PowerShell, which is what I've been on for the past 6 months mainly, and aside I kind of do a bit of Python, web stuff like HTML, CSS, and Excel. I have my own website, which is called Ucovi Data. Ucovi is based around a theory on data management fit for SMEs, and it has kind of a 25,000 words of blog on there. It has some Power BI infographics as well. Also has a kind of best of the rest kind of retweeting calendar compiler for the best data events on in London, the UK, and virtual. The company I work for is called Action BI, which stands for Business Intelligence. That's their barcode. Our kind of stack of technologies is mainly Power BI and SQL, but we're also doing some stuff in Power Automate, PowerShell, obviously, and branching out into Alteryx for some of our clients as well, and of course a bit of Python, a bit of C#. The main industries we serve are construction, energy, waste management, and food and beverage, and we're kind of looking to expand not only our client base but our staff base as well. So you can check the website out, and I'm not a shrinking violet on LinkedIn, so you can kind of find me there if you'd kind of like to, if you're further interested. But we'll just crack on with the talk. Now, what problem am I trying to solve with this talk? It's kind of this. This is the link to the instructions for regex in PowerShell that Microsoft provides. And it's very similar to the instructions that Python provide for their regex as well, and other languages that do it. They manage to be intimidating, yet at the same time incomplete. And they don't give you everything you need to know in an order that's kind of logical to them, and they give worked examples, which is great, but they don't really help you build up muscle memory in it, and they don't help you kind of find good approaches to debugging other people's regex, and also kind of building some of your own. So there's a kind of a gap in the market for this, I think. And because of this kind of gap, people do this all the time. They kind of, when they need to use regex, they amass all their regex knowledge by ad hoc Googles of query or GPT, if you kind of want it to be more polite but less accurate. And they kind of, so the saying goes that you learn regex 20 times and you use it 20 times, and that's very much the case. But it's a shame, because it's a very neat thing to be good at, and the need for it crops up more often than you think. And because people aren't building muscle memory for it, and it's perhaps not as popular as I think it should be, certainly, but the kind of alternatives to good quality regex are a very lengthy else if statement, which tries to capture all the kind of different spelling mistakes in the text that you're trying to search. Or people even do, they even make find and replace lookup tables within, say, an Alteryx data flow, or even in a SQL database, to try and match in string, to try and anticipate every single spelling variant or number formatting variant, and what it means and what it should be replaced by. And they're very, very readable, and that's an approach, but it's kind of seems a bit overkill and kind of awfully slow, and also it's gonna miss things. You can't really get everything in a table. So Regex is, to me, it's very powerful and it's very easy to learn, and especially in PowerShell, of all languages, it probably, I don't think, provides as good support and implementation for Regex as any language. Python has a very good implementation of it. I know it's in JavaScript and Java. SQL, you can do some good stuff with a pat-index statement, but PowerShell really gives you inline functions, and it gives you a group object for Regex which really gives you properties that mean you can really drill into it and reproduce the properties back from it for onward operations. It kind of makes it, it's very pleasurable to use. And I'm going to go through some examples of what I've done. So a concept prover is postcodes. So I've got, like, from lines 35 to 41, I've got real postcodes and fake postcodes embedded in address lines that are in different positions, different formats of postcode, and I've got, like, two fake postcode, which is an order code which looks like a postcode, and a postcode but hidden by other strings. And basically, you can use, like, one line of actual address regex does all of that. And there's, like, 7 different rules which constitute a UK postcode. So it's one line of code solving your problem. A real-life use case that we've come across at Action BI, we wanted to just check input files to load into a SQL schema. They were coming through in text, and some of the date time columns had UTC on the end of them. Some had 6 millisecond precision, some had 3. And kind of like the first one we came was the one on the top left, which is basically just replace +00 with the rest. But then and he wanted it specific. We wanted to use the IO file to do it as quickly and as readably as possible. But that's just that's going to replace everything with +00. So it's going to corrupt data where that's actually real data. So we basically use Regex to do it, and down below I've got Regex A, B, and C. And you can basically still conform to the import the IO file object, but then just using Regex. It's very long, but it's we'll go through an approach to breaking it down later. But it's become much more accurate, and it's going to replace everything without corrupting data where +00 is needed. And at Action BI, we've kind of gone to town a bit on Regex. The kind of next level example we've used is we want to try and create OneNote documentation using PowerShell for a SQL schema, also for DAX and M queries in a Power BI model. So this is essentially Regex to identify block comments in SQL statements, and I've just put a green arrow line around the hard one. You can identify a block comment by basically saying anything that starts with / asterisk and ends with asterisk /. But then the one I've highlighted, you're going to actually block out real uncommented SQL, because that's technically between that, and Regex is greedy, as we'll come on to later. So we have to use a bit of Regex and a while loop to actually teach it to identify the smallest distance of data between the comment starts and the comment ends, block those out from the next search, and then identify the ones outward, so that we start with the smallest and work our way out and don't hide actual code data. So I was quite pleased with that. And also the reverse engineering and debug. Well, this is I suppose we're on the why section. I think this is a big reason why. You might, in a bit of PowerShell code or in any language, you might inherit this from a previous developer. This is the line which does all my postcodes, and there's kind of solutions on Google, Stack Overflow, and ChatGPT for how do I build Regex to do this, but the other way around is much more difficult. You might have to kind of reverse engineer this and try and work out what it's doing. So that's why it's worth kind of building an affinity for it. So that's the kind of power and the use cases for it. It's basically cleaning data, validating its input, even analyzing and segmenting it, and being on call and ready to kind of debug regex, which perhaps isn't working the code or has served its purpose. But the essence of regex, what are we doing here? And I think I tried to come up with a good definition for it. The essence of regex is we want to identify accurately and exhaustively combinations of words, numbers, characters that may or may not be in the string or the raw data set, regardless of unimportant variations to them. So that's kind of, that's the postcodes, really. That's the kind of, we've identified 7 different patterns of UK postcodes. Ones in London have an X after there's the 4 and the 3, and then they all have, or there's a 3 and a 3, or there's a 2 and a 3. We know that. We know there'll be a space between them, and we know they'll often have punctuation either side. So it's basically accounting for all options and making sure we get every postcode, but not fake stuff that's not a postcode. And regex expressions are, in that sense, I think they're kind of single-line algorithms which model concepts as expressed in text data. That's kind of, if you want to be, in my more glamorous moments, that's what I tell my parents. What is regex in PowerShell? What does it boil down to? We've got strict. It's basically text and then the pattern that you search within it. It's special characters and pairs of characters which make the patterns that you're searching within the text more advanced. It's matching groups and brackets which build on the characters, which allow you to kind of repeat and ask for repetitions of what you want. And then in PowerShell, it's using the logic in the top 3 with inline text functions and regex objects, of which there are 3 to do replacements effectively and capture variables for use in onward replacement operations or to go into database variables. And then within these objects, especially the regex matches one, there's useful properties within that which help you do it. So we're going to cover this in detail. Special characters and character pairs. These are the special characters which work singularly, and these are the ones which work which are pairs. What do they do? So let's do top row left to right and bottom row left to right. The first one is the dot operator, which is a placeholder for any letter. So if you put a dot between 5 and 7, it says match 5, 7, and then anything in between it, so it'll match 3. The asterisk qualifies the one immediately before it, and asterisk means match any occurrence of these from 0 to any. So 5, 3, asterisk 7 will match 5 through 7 because it's asking for any occurrence of 3 between 5 and 7. But it was also match 57 because it's basically saying, if 3 is not there, don't worry, but try and find it, but match it anyway if it's not there. The plus operand is like the asterisk operand, but it says there has to be at least 1. So 57 won't match 5, 3 plus 7 because it's asking for at least 1 instance of 3. The pipe is very important. It's basically says or. So 7 pipe 8 means match 7 or 8 within this string. So this will match because it contains 7 or 8. The 2 square brackets create a wildcard. So between the 2 square brackets, you've got A to Z, 0 to 9. That only means 1 letter, but it says this letter can be A to Z, any of the alphabet or any of the number. And the dash A to Z and 0 to 9 is basically shorthand for writing all the letters out and doing all the numbers out. But so A to Z, 0 to 9 will match anything in 5, 7, 8, 8, 8. The curly brackets qualify a square bracket wildcard and appear after it to say, well, how many times in a row should this match? So and it has a minimum and a maximum, and the minimum's encoded from 1. So this is saying get A return the match. This will successfully match if A appears twice, 3 times, 4 times, 5 times, or 6 times. So in this case, it will work. Let's have a look. Right, the parentheses create a group. So and a group is a group serves two. So its main function is to get is to deal with the is to give you that as a separate entity in your return statement when you're matching. So basically, and it also groups can be back referenced, so you can refer to that later in a regex statement itself. So A to Z is so basically 5AA8 will match this because it will give A twice, but A twice will appear in a group, so you can pick that out. A backslash, very important, escapes the wildcard. No, it doesn't. A backslash is a special character escape. So the dot, as we've seen before, means match anything. But if you put a backslash before it, it means match it literally as a full stop. So this will match 57. Okay, $5 means it has to appear specifically at the end, and caret means it has to appear specifically at the beginning, unless the caret is within another letter in a wildcard, and it's in which case it means don't match 5. So match anything but 5. So that one will fail. The pairs, \space means match spaces. \word means match any letter, number, or underscore character. \w is the opposite of that. So it'll match the ampersand. \d means match any numeric character. \capital D means match any non-numeric character. And \1 means match any works after a group and says if you identify a group, \1, that references the group, so match what's in the group and match it again, and that's really helpful. Okay, so as we've slightly covered before, square brackets is what's referred to as a wildcard. The curly brackets is the constraint for it constrains the wildcard's minimum and maximum length. The curly brackets is a group, and \1 is a back reference group. So I'm going to just cover a quick example. I think I'm going to run out of time a bit on this, but Florin Radicchio is real. He's a Romanian footballer from the 1990s, and John E. is a random form fill from a hacker. I want to identify Florin Radicchio's last name as real and John E.'s name as fake, with a simple repetition of vowels means fake. But Florin Radicchio and John E., if I'm just going to wildcard match them and say any vowels 4 times in a row, it's going to match both, because Radicchio is basically vowels 4 times in a row and John E is 4 times in a row, E and I O. But if I group them up and put AIU in the group and then back reference the group and say, give me the group plus, and then that syntax for back referencing says the group itself plus 3 times afterwards, won't work on Radicchio because IO and IOU are not the same vowel, but it will work on E because they are the same vowel, and that's the power of grouping. Take the best QR code you've ever had, multiply it by 1,000. That's only half as good as Regex and PowerShell. That is the QR code for the questions. We'll probably get one, so make it a good question. The methods and the object for Regex. Match and replace is essentially find and replace. But cReplace and cMatch, they're case sensitive. So the default for PowerShell regex inline is case insensitive. So if you want to do it case sensitive, you need to put C on the start. And if you want to pull out a group from your match in inline, you do $ and then 1, and then 1 being the order of the group. So if you've got more than one group, that's 1. Match objects, you've got regex matches returns all the matches. match returns the first one, and is match returns a Boolean for has it matched or not. If we have a look at a simple match with with no groups, this will give you 2 matches because you're asking for 0 to 955. But you'll then, if you group it up, you'll get 1 match, and I've grouped it up there. But then you'll get a group in there, and you can then call the first group, which is 55. You can see the difference. The length is different. It's the length of the top one for the general match is everything, because the first bit is a group and then you've said space at the end of it, but you've grouped the numbers, so the second one is just the number group. Regex is a greedy. This is a quote within a quote. It'll match everything, so you've just got to be aware. There's also look aheads and look behinds, but I don't think they're that important. I think you can just do them using clever groups. And if we just do the postcodes, just a quick tip. I'll go to the joke. It's a bit like what Molly Brown said to Leo DiCaprio on the suit when he's faced with a caviar spoon. Start on the outside and work your way in. So break it down by looking for that's the big postcode one. But look for the groups on the outside. Once you've identified them, you've identified blocks. You're kind of simplifying it. Then once you're within the groups, look for the pipe within the groups, and then look for the wildcards within the pipes. That's the way to start from a big thing and condense it into its small constituent blocks. I think we better finish there. Here's my company QR code again. Yeah. Ooh. Sorry. Which contain incompatible. Can regex expressions be directly ported between language and platforms, or are different variables which contain incompatible syntax? PowerShell and Python, I think, are your big ones. I think they're actually neck and neck, dead ringers for each other, but just PowerShell will escape new line character, does escapes with the character at the top right of the keyboard rather than a backslash. That's the only difference. It's all about how advanced they are. PowerShell and Python, the most advanced, are the most very similar. Cool.